Hi everybody. We are currently in a unit on polynomial functions, and we have certainly been talking about operations on polynomial functions, but it's probably a good idea for us to pause and take a look at the general formula of a polynomial function, which is what I have right here. Now, a polynomial function, if you'll notice, it has all of these coefficients, and the coefficients must be real numbers. So they can be fractions, they can be decimals, they can be anything we want them to be. I mean, we could even have pi if we wanted. But we also have each of those coefficients is being multiplied by a variable, typically x, to a power, and that power must be greater than or equal to 0, and it must be an integer. We can't have any powers like a negative 1/2, or even a positive 1/2, or even a negative 3. One of the important features in a polynomial function is the degree. Now we can find the degree of any term, and that really is just what is the power. So if we were looking for the degree of the entire polynomial function, it's going to be the highest power of the polynomial function. So let's take a look at example 1. We have y equals x to the 4th minus 2x squared plus x to the 5th. Notice that the highest power here is 5. So this is a 5th power function. The degree is the 5th power. And I'm sorry, we could actually just say that that's degree 5. Why don't we do that? Get rid of that. Let's just say degree 5. Now that's important because it tells us a little bit about our function. Because it is degree 5, we know that this is called a quintic polynomial. Now, example 2 is a little bit different because now we have y equals x plus 4, the quantity of x plus 4, times the quantity of x squared plus 3x minus 1. In order to find out what our degree is, we would kind of have to distribute that x plus 4 into x squared plus 3x minus 1. And in the end, we would see that when we multiply the x times x squared, we would get x cubed. That would be our highest power, so we would have a degree of 3. And since we have a degree of 3, we know that this is a cubic function. We can also have quartic functions and quadratic functions and linear functions, which you're also very familiar with. There are others, but we don't usually take the time to name them specifically. One of the things we need to be able to do with a polynomial function is write it in standard form. And it's pretty straightforward. In standard form, the terms are written in descending degree. So if we take a look at our example from the last slide, we had y equals x to the 4th minus 2x squared plus x to the 5th. So if we want this to be in standard form, the highest power goes first. So this would be y equals x to the 5th plus x to the 4th, and finishing out with minus 2x squared. So the powers are kind of going in descending order, or the degrees are descending. To do example 2, we're going to really have to multiply this out first. And we've already talked about this. We know that x times x squared is going to give us x cubed, which gives us our degree 3, making this a cubic. But we're going to have to keep going. And I'm just going to kind of multiply that out using distribution, and I'm going to get, when I distribute the x, that's what I'm going to get, x cubed plus 3x squared minus x. When I distribute the 4, I'm going to get plus 4x squared plus 12x minus 4, and I'm just going to combine like terms and put them in order so that we have this in standard form. So we only have one cubed term, but we have 2 square terms giving us 7x squared, and we have 2 plain old x terms giving us 11x, and then we have one constant of minus 4. I think that's pretty straightforward for you. Okay, so this is what we've been doing the last couple of days. We've been performing some operations on polynomials, and let's just do a little practice with this. The functions we're going to be using will be f of x equals x squared plus 2x, and g of x is x squared minus 1. These may seem a little bit more complicated than what we've used in class the last couple of days, but it's okay for some good practice. If you'd like to try these on your own, that's fine. Go ahead and pause, do the problems, and then when you're ready, come on back. Okay, so let's go ahead and work these out, check our answers. So f plus g of x we know is going to become x squared plus 2x, right? Plus x squared minus 1. When we combine like terms, we're going to get 2x squared plus 2x minus 1. Yes? Okay. When we subtract f minus g, it's going to look very much the same. We're going to have x squared plus 2x minus, the parentheses become important, don't forget, and that's going to be minus the quantity x squared minus 1. There we go. And when we distribute and simplify that correctly, our x squares are going to cancel out, and we're going to be left with 2x plus 1. Be careful of your signs there. And let's just box that in blue as well so you can see it. Okay, so far so good. Just be careful here. Make sure that you are distributing minus times the negative 1 to get that plus 1. And if we're going to multiply, now notice this symbol right here is a dot, so it's just multiplication of f of x times g of x. So we're going to have x squared plus 2x times the quantity x squared minus 1. And it's kind of like foiling, really. We won't have quite as much to simplify, but that's okay. So we're going to get x to the 4th. We're going to get, first, outer, we're going to get negative x squared. We're going to get positive 2x cubed, and we're going to get minus 2x. Now, you might have done this in a different order, so you could wind up with standard form in the end, but I'm just going to rewrite it. X to the 4th plus 2x cubed minus x squared minus 2x. And that's our final answer. Make sure it's in standard. Whoops. Make sure it's in standard. Whoa. Our little boxes are getting crazy here. Let's try this again. There we go. All right, and finally, composition. Be careful with composition. Remember that composition is the open circle like we see right here, and composition does not mean multiply. It means plug in. So what we're going to do is we are going to actually plug in g of x for f of x. So that means we're going to have something squared plus 2 times something, and that something that we're going to have is whatever g of x is, which in this case is x squared minus 1. And when I plug that stuff in, now I've got to simplify. It becomes a little more complicated. And x squared minus 1 quantity squared is going to become x to the 4th minus 2x squared plus 1. And when we distribute over here, we're going to have 2x squared minus 2. And finally, when we combine like terms, x to the 4th, notice they are 2x squared and our x squared are going to cancel out, and we're going to have minus 1. And let's just put a box around that. Oy. Minus 1. And we'll put a box around that. There we go. Off the screen. All right, so hopefully that will help you, and good luck tonight's homework. You're going to be great. All right, see you tomorrow.